Alright, for this problem we're going to be looking at closed manometer problems. And so we have a closed manometer with mercury. It's attached to different flasks with gases in order to measure their pressure. So given the results for each, we need to sketch the manometer and give the pressure. Okay, so in the first case we have mercury height 423 millimeters higher on the side away from the gas, and we have the mercury height 56.3 centimeters higher on the side away from the gas. This first problem where we have 423 millimeters higher on the side away from the gas, we could go ahead and sketch it. I've done that already. It'll look okay. So you can see right here as we look at this manometer, the gas is over here in this flask on the left. That is pushing the pressure this way, and it's going to push down on the mercury. On the other side, that is going to therefore push it up this tube. Okay, up here it's a vacuum. So really the pressure of the gas is pushing down. The pressure of the column, that height of column of mercury, is pushing down, and those are offset because this thing is static. So we have a case where we can write out the equation. The pressure of the gas is equal to that height in mercury. Okay, so for the first part of this then, we know that it is 423 millimeters, so 423 millimeters of mercury is the pressure of the gas. If we want to give the answer in atmospheres, okay, we're just going to simply convert that 1 atmosphere over 760 millimeters of mercury, and we're going to come out that the pressure of the gas is equal to 0.557, just throw a 3 and 0 in front of that, atmospheres. Okay, so we're going to go to 3 significant figures here, so you would get 0.55657, and you just round that to 0.557. So this is the pressure of the gas. Let's look at the second problem. So in this problem, we have a case where the mercury is now 56.3 centimeters higher on the side away from the gas. So it just depends how you measure it. Okay, keep in mind, though, that when we draw this, we have the same exact thing as before. Okay, pressure, gas, height of mercury. In this case, our H is this 56.3 centimeters. Okay, one of the things to be aware of is centimeters of mercury, we can't directly convert that, so we're going to convert that first to millimeters of mercury. So we have 56.3 centimeters of mercury, and we know that when we do this out, that's going to be 10 millimeters for every 1 centimeter. Okay, so what we have is 563 millimeters of mercury. If we now take that value and we want to convert that to atmospheres, we simply do 563 millimeters of mercury, 1 atmosphere over 760 millimeters of mercury. Those cancel out, and at the end we get that the pressure of the gas is equal to 0.741 atmospheres. So that's how you do a problem with a closed-ended manometer. If you have an open-ended manometer, you can take a look at the open-ended manometer video for some sample problems.